Dear student, you may not have noticed this, but what I have been doing is I have played a little trick of misdirection on you. Do you remember when, after showing this image, I mentioned that compaction on its own is still not the only variable that defines a soil's strength? I also went on to mention that we would get to that a little bit later, as in, we would get to what the other variables were that affected a soil's strength other than compaction. Well, I fibbed a little bit. I actually got into it right away when I started reminding you about the Proctor density test. Let's first establish a few key concepts. First, soil density, as defined for the Proctor test, is equivalent to that soil's degree of compaction, also known as its bearing capacity, which is actually that soil's ability to support more or less weight. Second, and I know this is review for you, water content, which is the percentage of water in a soil sample, and it is calculated by dividing the weight of the water in that sample, W sub W, by the weight of the solids, that is the dry soil, W sub S, multiplied by 100%. A reminder that this and other formulas are provided for your review both on Blackboard and in your previous set of course notes. And now, for the big reveal. A soil's strength is not only influenced by that soil's degree of compaction. It is also influenced by how wet that soil is. Remember? That is exactly what we investigated in the Proctor density test. Oh, and guess what? We will actually reinforce this concept during the performance of Lab 3 coming up.